Okay, class. For the final topic, we will be covering sampling. Okay. Why do you need to do a sampling technique? Because statistical inference permits us to draw a conclusion for population based on a sample, and sampling is often done for these two particular reasons. Cost, because it is less expensive to sample, let's say, 1,000 food handlers, maybe dalam Terengganu, as compared to pada 1 million uh, of the whole state of Terengganu. And of course, number dua, practicality. Sebab logik lah, takkanlah you nak go sampling daripada pengedai, daripada penjual gerai kuih, daripada besut sampai ke Memaman. God knows how long you will take if you take the approach. So that's why we do the sampling, which is we select a statistically justified amount of population to do our study, whether it be survey or interview or etc., and get a general and get a finding that is easily generable or at least applicable to a selected population. Okay. In that case, the sample population and the target population should be similar to one another. Okay. Now, generally sampling ni ada dua. Satu ialah probability sampling, in which the element of the population will have a known chance of being chosen as subject. Yang kedua ialah non-probability sampling, di mana elemen in population do not have any probability attached to their being chosen as sample subject or not. So, keyword dia probability, kebarangkalian, non-probability, tak ada kebarangkalian. Meaning, kebarangkalian ni everyone has equal chance to be chosen, while non-probability sampling, kalau study you spesifik pada food handlers di restoran, meaning food handlers di restoran saja dipilih. Food handlers yang kerja dekat kilang, yang kerja dekat pasar tak akan dipilih. Okay? Tapi kalau you luaskan scope, you kata food handlers in food industry, it has a bigger approach. Meaning kilang boleh, orang pasar malam boleh, restoran boleh, ataupun yang buat online delivery semua boleh. Okay. Alright. So let's look at some of the sampling methods that apply under the probability sampling. The first one is the simple random sampling, in which, as you can see in the example, a restaurant manager have asked to consider formulated a flexible work time policy. 1,000 elements in the population need a sample of, but let's say kalau KFC Terengganu ada 1,000 staff, tetapi untuk state manager buat sikit survey tentang flexibility working time policy di KFC, dia mungkin perlu 100 saja. So ada dalam 1 per 1,000 orang, or 1 to 99% chances that anyone from Besut, from Hulu Terengganu, from Setiu or Kemaman or Dungun to be chosen. Okay. Atau bukti kata lain, kita kalau you tengok ilustrasi gambar ni, 1,000 nama letak dalam box, kita perlu 100 saja. So the researcher akan pilihlah 100 and ikut chance atau nasib siapa yang kena. Okay. So kalau nak senang ingat single random sampling ini, ingat cabutan bertuah. Okay. Sampling is the stratified random sampling method. As you can see in the example, if an HR director is interested in accessing the extent training that the employees in the organization need, dia mungkin boleh bagilah dalam berapa strata. Okay. Alright. Strata atas ni mungkin mewakili manager atau assistant manager. Strata tengah mungkin supervisors and team captains di restoran. And strata di bawah ni the normal waiter, runners and so on. So by dividing dividing the organization into groups, or in this case stratas, kita boleh decide dan determine lah apakah, dan kita buat punya survey. Misalnya kita nak kaji contoh apa training kompetensi yang diperlukan oleh top managers, middle managers dan juga service crew. Okay, dan training yang diperlukan untuk setiap grup tu mungkin berbeza, dan soalan yang akan ditanya pun akan berbeza ikut level of employment, okay, ataupun taraf jawatan. Okay. Alright, another variation of the systematic random sampling. Kalau contoh kat sini, kita perlu ada 100 number, kita perlukan 20. Tapi daripada 20 tu mungkin kita berselang-seli, meaning kalau simple random sampling mungkin you mungkin akan ambil 1, 2, 28, 56, 60, kemudian skip this section and terus ambil 70, 80 and terus ke 100. But to systematic random sampling mungkin you bahagikan. Okay, kalau dalam 100 dan you nak 20. So you akan pilih ikut the first batch, katakan 20, meaning 20 kali kalau kita bahagi 100 bagi 20, meaning there are 5 subgroups. So between these 5 subgroups, you akan pilih berapa? Dalam 50, dalam 5 hingga 6 until you reach the amount of 100 or whatever sample that you need lah. Okay. Alright. Another example will be the clustered random sampling. Okay, clustered sampling ni, cluster merujuk pada kelompok lah, kelompok population yang kita nak pilih. Misalnya kita nak buat kajian tentang maybe HACCP or GMP knowledge of kilang keropok di seluruh Malaysia. Tetapi kilang keropok ikut negeri mungkin berbeza. Penang mungkin tertumbu, mungkin tak ada kilang di Georgetown tetapi tertumpu di seberang Perai. Di Terengganu kilang-kilang besar mungkin tertumpu di contohlah Kuala Nerus atau Terengganu. So katakan kita nak buat a statewide study of GMP has a knowledge of keropok factories throughout Malaysia. So ikut setiap negeri kita akan zoom in and aim in dekat mana kilang keropok tu tertumpu, dan kita akan pilih di situ, dan kilang keropok tu akan represent the keropok production di negeri tersebut lah. Okay. Alright. Meaning tak perlulah kita ambil kalau ada 13 negeri, satu negeri tu tak perlulah sampai 2-3 cluster. Kalau tak perlulah, just select a cluster or where of your simple population is situation. Kalau macam saya kata tadi, kalau kilang keropok tu bertemu di Kuala Terengganu, Kuala Terus, just ambil yang tu saja, walaupun maybe akan ada sikit di Besut dan Hulu Terengganu, tetapi you boleh ignore sebab dia punya concentration mungkin terlalu sikit. So choose the one that has the most representative of the state, and also apply the same concept when you take samples from the other 13 states for your nationwide studies relating to HACCP and GMP knowledge in Penangkapan. Okay. All right, so that is some examples of probability sampling. So what about non-probability samplings? Okay, the most obvious choice, the most obvious one kalau kita tengok non-probability sampling is of course convenience sampling lah. Meaning kita pilih siapa sahaja yang ada di tempat kejadian di masa yang kita nak buat kajian tu. Macam saya sebut dalam kelas hari Ahad itu, lazimnya convenience sampling ni sangat-sangat favorable kalau kita buat pilot study lah. Okay? Sebab mungkin kita hadapi kekangan nak tunggu lulusan etika kalau kita nak buat a real pilot study in the real setting. Sama ada nak masuk hospital ke, nak masuk restoran franchise ke. So, buat pilot test tu dalam population yang senang didapati. So, kalau universiti, maybe kita boleh approach professor, kita punya lecturers, kita punya lab staff, and kita punya kawan-kawan kat rumah. Okay. But kalau kita buat convenience sampling in the real world, not to say benda ni tak bagus apa, tapi dia ada pros and cons. Just make sure kalau you nak pilih convenience sampling ni, at least write a strong justification lah kenapa you guna convenience sampling ni dalam study you. So example, kalau you ada launch produk baru, keropok pisa cili contohlah, dan you nak pasarkan, you nak tengok acceptance of orang. So the easiest choice maybe kalau tak buat dalam universiti, mungkin you boleh buat market survey ni di misalnya Giant ataupun Maidin. Lepas you dapat kebenaran daripada pihak pengurusan to set up stall, mungkin daripada pukul 8 ke pukul 10, just approach siapa-siapa saja yang lalu sini, tak kisahlah dia student ke, dia student universiti ke, pelajar sekolah ke, staff UNT Uniza yang tengah lunch break ke, just for the sake of convenience untuk test you punya acceptance of new product, pilih siapa-siapa saja. Okay. Alright. And second example will be quota sampling. Alright, quota sampling ni apabila kita setkan group tu. In this case, dalam satu senario kita nak kaji misalnya kepuasan terhadap perkhidmatan umrah lah untuk pergi ke Mekah, Madinah oleh contohnya Andalusia Travel. So kita nak tengok dia punya full experience daripada flight, daripada accommodation hingga balik. Maybe kita kena setkan dah untuk survey ni, kita setkan kita mau 60% male, 40% male daripada satu seorang. So kita dah set 60 yang kita pilih daripada jemaah ni mesti daripada lelaki dan 40 orang mesti daripada perempuan, daripada jemaah wanita. Dan survey ni dibuat katakan pada Januari 2021. So that's data collection hanya valid untuk that period of time sajalah. Kalau dia buat longitudinal study, mungkin dia kena gather another round of samples, another round of survey using the same quota or different quota. Okay. So that's quota sampling. Alright, the last one will be snowball sampling. Bukannya sini you ambil salji baling kat orang. But snowball, kalau ikutkan ilustrasi gambar ni, apabila you roll daripada kecil, dia jadi besar. Now, konsep snowball sampling ni, it applies when the subject is hard to difficult or to trace. Contohnya, you nak kaji tentang apa? Aktiviti penyelundupan beras daripada Siam masuk ke Kelantan. You nak, meaning sangat sukar lah kalau you nak survey, interview penyelundup daripada Thailand dan apa? Dan Kelantan tu, sebab kalau you dapat sekalipun sila hari bulan, pistol ataupun pistol boleh letakkan atas dahi tu, ataupun pisau diletakkan di leher you. Sangat dangerous. So since you tak boleh approach the smugglers ni secara direct, what can you do? So kalau you apply konsep snowball theory ni, you mungkin you tak dapat direct smugglers tu. So apa pertalian yang ada smugglers dengan makanan ni? Pertalian pertama mungkin dari segi pihak immigration. So mungkin you boleh interview dan tanya, you start dengan interview ataupun survey pihak immigration. So peringkat pertama, you tanyalah pegawai atau pengarah immigration dalam setahun berapa orang ditangkap dan sebagainya, apa yang diorang sudut sebagainya. Okay. So lepas you dapat information from that first stage, you roll to the next stage. So the snowball rolls. Mungkin you approach jabatan pertanian misalnya, contoh. So tingkat kedua, you akan do an interview or survey session dengan orang jabatan pertanian untuk tengok berapa dia orang rugi, macam mana dia orang kawal pergerakan, kawal dia punya production supaya tak ada ketirisan. Okay. Peringkat ketiga mungkin pergi kepada another authority, maybe polis ataupun polis dan cabangnya. Polis yang, sebab dalam polis dia ada satu cabang which is special branch. Special branch ni relates to intelligence lah. So peringkat ketiga you tanya special branch, tengok and dapat sikit maklumat macam mana dia orang trace dan tangkap penyelundup yang bawa beras daripada Siam masuk Kelantan ni and vice versa. Berapa lama dia orang kena undercover, cara mana dia orang undercover, right? So peringkat peringkat tiga. Peringkat keempat, mungkin you boleh interview orang kampung yang tinggal di sempadan Thailand, Malaysia ataupun di Kelantan tu. Sebanyak dapat information pada orang. Selalunya bila pihak kuasa akan standby, bila dia orang tahu ada maklumat lori ataupun kereta akan lalu area kampung sempadan untuk seluduk beras, adakah dia orang ni pernah disogok oleh penduduk supaya dia duduk diam supaya tolong simpan bahan makanan. Okay, so that is an illustration sample of how snowball sampling is done, ya. Apabila you buat satu topik ataupun satu kajian yang agak risky or difficult to trace, you pergi survey atau interview orang ataupun entiti peringkat demi peringkat dapatkan maklumat yang you perlukan lah. Okay. Alright, so those are sample of non-probability sampling. Okay, so you'll be wondering how big should your sample be? General rule of thumb, lagi besar, lagi bagus. But not too big, don't be too ambitious. So let's see what the rule of thumb by Roscoe means. Roscoe kata kat sini, N should not be more than 30 and not less than 50 for more research. Okay. Apa lagi kata? mungkin ada tak? And rasa tak ada dalam slide ni kot. Kalau you boleh search Credit Morgan basically state for any research, N should be 373 for most social science research. Roscoe bagi within this range. Saya ada contoh, ada rule of thumb, saya kena tunjuk ke website. Ya. Okay, kalau you tengok screen sini, this one is the rule of thumb by Sudman, 1976, adopted by Aker and Hare. Dia ada breakdown of how a nationwide study or a regional study can be conducted. Kalau you tak ada any subgroup ataupun sikit saja, national level dia kata kat sini, acceptable between 200 to 500. Kalau you buat regional, between 50 to 200. Kalau you ada average amount of subgroups, mungkin you boleh consider 500 to 1000 for a national study, 200 to 500 for a statewide or a regional study. And the same applies if you have many subgroups, more than 1000 or more than 500. Okay, so this is another example of a rule of thumb, and this one is by it's actually Sudman 1966, but this has been adopted by Aker and Hare, right? But if you somehow manage to get a statistic of a certain population or prevalence of, misalnya contoh penyakit kronik ataupun malnutrition for whatever, you can use those figures and select any appropriate sampling calculation to calculate the population for your studies. But that will be up to you to decide and explore which sampling method calculation you want to use. But if some way somehow you tak tahu apa population misalnya staff yang datang ke cafeteria, you can always use the basic rule of thumb berapa as stated by the researchers yang saya tunjuk tadi. Okay. Alright. Okay, these are some of the considerations you need to think about when choosing sample size. First is the degree of precision required between the sample and population. It will be you will have less precision if you choose a small sample. Number two is the variability of the population. A more homogeneous population requires, but if you want a homogeneous population, it may require a small sample population. Okay. Method of sampling, a stratified sampling requires fewer cases for accuracy. And number four, maybe ways in which result will be analyzed. Okay. All right, common errors that occur during sampling, there are dua jenis, which is the sample error and the sampling error and non-sampling error. Sampling error kita boleh rectify dengan simply tinggikan bilangan sampel yang kita ambil tu supaya kurang errornya dalam sampling error. Tetapi kalau non-sampling error complicated sini sebab dia mungkin melibatkan faktor seperti error masa you collect data tu, meaning you punya instrumental tu tak valid ataupun kurang reliability, respond rate terhadap questionnaire atau survey you tu somehow sangat rendah, ataupun maybe selection bias di mana katakan you buat study tentang tentang eating habits of instant noodles among youth. Youth tu luas, remaja. Tetapi dalam study you, mungkin you tertumpu pada pelajar universiti je dan you tak peduli pun budak sekolah atau budak sekolah menengah ataupun sekolah ni. Sedangkan itu pun dikira sebagai youth. So situ boleh jadi error lah, non-sampling error dalam research you. Melainkan kalau you dah specify study of instant noodle consumption ni is among university students saja. Okay. Alright, untuk lebih detail saya akan tunjuk video ya, which explains briefly but detailedly what sampling error and also non-sampling errors are about. Saya buka YouTube dah. Oops. YouTube. Okey, kita tengok dulu apa tu sampling error.
Sampling variation, which is also called sampling error, and how it is related to sample size. The research question we'll be thinking about is how far people walk each week. If we think about the entire population, it should be the case that everybody doesn't walk the same number of steps each week. That is, maybe this person takes 56,932 steps in a week, and this person takes 62,157, and this person only takes 49,238 steps, and so on. What we're seeing here is a type of variation called natural variation, the tendency of individuals within a population to have different values of a variable. And when we take a sample from the population, we can see this natural variation from the population also appearing in the sample. And we can estimate this natural variation using measures like the standard deviation or interquartile range. Now, there is another type of variation that is important in statistics. In our sample, we can compute a statistic such as the sample mean. Pause the video for a moment and think about the following question. Is this sample mean equal to the population mean? The answer is, well, we don't know. Because we don't know what the population mean is. We don't have data from the entire population. But it seems unlikely that this sample mean would be exactly the same as the population mean. And this phenomenon is called sampling error, because the sample statistic is not equal to the population parameter. Let's go back to the population and think about this a bit. What if, instead of our original sample, we had randomly selected a different group of 10 people? And we collected data from everyone in the sample, then looked at the distribution of these data, which would again be a distribution of a sample, and would have its own sample mean. And if we think again about the entire population, we can see that there are many, many possible samples of 10 people we could have randomly selected from the population. And because there is natural variation in the population, each sample will have a slightly different sample mean. Then we could think of the collection of sample means as a set of data itself. And we could look at the distribution of these sample means as a histogram. So each data point in this histogram is a different mean from a 10-person sample. And we can see that different samples have different sample means. This type of variation is called sampling variation, which is the tendency for different samples from the same population to produce different statistics. Sampling variation is produced by a combination of natural variation in the population and the random aspect of the sampling process. And much like the way we measure natural variation using the idea of standard deviation, we measure the amount of sampling variation using something called standard error, which is the standard deviation of the sampling distribution. You might be wondering whether you can avoid sampling variation. Alas, the answer is no. As long as there is natural variation in the population and you're taking a sample using a random process, then there will be sampling variation. But you can reduce the amount of sampling variation. Let's think about how to do this.
So rule dia kata sini, sample error you tak boleh hapuskan. Somewhere somehow akan berlaku juga, but you can reduce it.
So here is our original 10-person sample. Assuming we used a good sampling method, the mean in this sample will be reasonably close to the mean of the population. But now imagine that we randomly selected 20 people for our sample instead of 10. Since our sample is larger, it should do a better job reflecting the natural variation that is present in the population. Consequently, the mean of a larger sample will be closer to the population mean. Let's think about how this impacts sampling variation. Now, instead of 10-person means, we're going to take samples of size 20 and compute a mean for each sample. And each of these sample means will be closer to the population mean and, therefore, to each other, which reduces the amount of sampling variation. Now, let's recap what we've seen here. We looked at the concept of natural variation among individuals in a population and saw how the combination of natural variation and sampling produced sampling variation. Sampling variation is measured by standard error. And finally, we saw how increasing the sample size reduces sampling variation, and thus the standard error.
Okay, so that's sampling error. Now let's see what non-sampling error is.
So what we want to do here is think about our key idea. And the key idea is that we want data that is representative. So if I'm interested in teenagers, I want a mixture of ages, genders, ethnicities, hair colors, device types, family incomes, you name it. I want a mixture of all of those so that my data is representative. Okay, so there's two ways that we can take a sample. One of those ways is by taking a random sample. The other is by taking a biased sample. So if we take a random sample, that means everybody has the same chance of being chosen. Whereas the biased sample is not. Some people will be chosen and others won't, but the probability that being chosen is different. So if I was to choose just the students sitting nearby, then that would be a biased sample, and only those that are sitting nearby have any chance of being chosen, and others sitting further away have no chance of being chosen. So here's an example of what a biased versus representative selection of lollies would be. A bias means they're all jelly beans, okay? They're all similar in some way. Whereas representative means there's a mixture of different lolly types, different colors, different sizes, different flavors, all of those things. So if I want to be randomly choosing them, I will get a mixture of characteristics. So things like different genders, ages, sporting preferences, ethnicities, cultures, family type, you name it. Everything that makes us who we are will be completely mixed with a random sample. So for an example, if I'm doing a questionnaire with only blue-eyed students, that means that I've only got information about people that have got blue color eyes. I don't have any information about anyone else with any other eye color. So that means my data does not represent all people. It only represents people with blue eyes. Okay, so let's have a look at this exercise. So OEC has about 650 students. Students want to do a survey on the use of phones. So we want to state below if they are biased or representative samples. So interviewing all students in year 13 class. So I want to survey on the use of phone by students. So if I'm just taking a year 13 class, then that is going to be a biased sample. If I interview every 20th student, that means everybody is just randomly walking past me, so everyone has an equal chance of being chosen. So this would be a random sample. Therefore, this will be representative. Okay. 40 volunteers. So people who volunteer, are they going to be others? Is that the same? And in this case, it's not. This will be a biased sample. Okay. our volunteers may think or be different in some way. Okay, interviewing students at a sports game on a Wednesday afternoon. Does everybody in the school have an equal chance at being selected? No, they don't. It's only people who happen to be at the sports game on a Wednesday afternoon. Okay, so again, this is a biased sample. Only students who are at the sports game have a chance to be chosen. Okay.
All right, so those are explanation relating to sampling errors and non-sampling errors. Okay, sampling error kita boleh kurangkan. Saya recap balik, kita tak boleh hapuskan, kita boleh kurangkan dengan meningkatkan sample size kita. Tapi non sample errors agak berat dan kita kena berhati-hati sebab dia boleh berlaku dari segi data collection acquisition, non-response error ataupun selection bias. Jadi kita tak pilih sampel yang mewakili target kita dalam study ini. Kalau kita by definition, bukan saja pelajar universiti, kena include juga pelajar sekolah, teenagers. Okay. And as acquisition in data, error in data acquisition, mungkin dari segi structure interview ataupun structure questionnaire you belum cukup lagi bagus dari segi validity atau reliability-nya, menyebabkan you punya respond rate tak berapa bagus ataupun respon you dapat tu tidak seperti apa you harapkan. Okay. Right, so that's basically it for today's class, the final lesson. Are there any questions or comments that need address? Ada apa-apa soalan tentang sampling? Sorry. Sampai 40 minit. Right, so hopefully bila you buat kita ataupun murah rezeki lanjutkan postgrad, masters, PhD, you sikit sebanyak tahulah macam mana you nak pilih sample size population you, who and how much. Okay. So prinsipnya ni, kalau you ada population or prevalence something, you boleh guna certain formulas to calculate for your minimum sample size calculation. But yang tu tidak diajar pada peringkat ni. You boleh explore, you kena explore dan make evaluation nanti. But yang penting at this stage, kalau you tak cukup untuk you tahu, kalau you somehow tak ada you tak ada statistic on population or prevalence something, you can use general rule of thumb, sama ada disbursement, credit margin ataupun Roscoe tadi. Yang saya boleh simpulkan kat sini, generally ketiga-tiganya recommend at least dalam 100 hingga 500 orang for a regional studies. Kalau you buat statewide study, mungkin you kena statewide ataupun kajian satu negara, you kena ambil maybe above 500 to 1000. Okay, alright. So kita akan sambung esok dengan exercise exercise kita sebelum kita buat test SPSS minggu depan. So saya akan upload data sheet dan juga set soalan dalam bentuk words dalam e-learn at least sebelum pukul 2 esok. So saya akan inform nanti dalam grup, pergi download dan jawab soalan tu dalam Word document tu ya. Lebih kurang dalam pukul 3 suku, 3:30 kita akan online dan kita akan discuss answer. Alright? Okay. Alright. Pesan saya, jangan takut, jangan panik. Kita kena practice, kita kena hands on dulu baru kita akan develop the skill and knowledge tu. Okay? Jangan risau, soalan yang akan soalan yang ditanya tak akan lari daripada apa yang you belajar selama ni for all the 4 topics tu. Okay? Yeah, and so on. Jangan takut get your hands dirty and you are bernasib baik sebab saya practice session ni akan buat 2 kali. So hopefully by 20 bulan tu semua dah insyaAllah dah terror lah. Okay. Alright, before we end the class, ada apa-apa? Jangan laju sagu. Okay, tak apa, kita ada sampai pukul 5. Kalau perlu penjelasan semula 3-4 kali, just voice out. Saya demi you all, saya sanggup buat. Jangan laju dulu. Boleh bah kalau. Okay. Ada apa-apa soalan atau pertanyaan ataupun any luahan? Tak ada luahan. Alright. Semua tak sabar nak ni ke? Nak go for one last afternoon tea ke before PKP esok? Ataupun nak order suruh Grab food Panda hantar je kat rumah. PKP banyak. Masak. Okay, masak scone ke? Ataupun masak buat sandwich atau pie je? Tapi yang tanya dah. Atirah ni. Masak lauk ni. Okay. Kalau dah leftover buatlah chicken pie ke ataupun beef pie ke. Minum teh. PKP darurat. Darurat insya-Allah bukannya darurat macam zaman komunis tu, darurat dari segi pentadbiran saja. Means ahli politik yang mementingkan diri sendiri pada rakyat tak boleh buat kacau. Apa masalah tadi? Okey, boleh share. Okey, alright. Rasa hari ni groceries ke? Groceries dah beli pagi tadi. Isteri dah beli tadi. But Terengganu PKPB in a way still masih boleh keluar tetapi kena jaga anak-anak je lah. Okay. Okay guys, saya kita end this class di sini saja. For Muslim kita tutup dengan tasbih dan surah Al-As. Bismillahirrahmanirrahim. Okay kelas, thank you very much. Boleh makan lunch, boleh order food Panda ke food Grab, and happy afternoon tea again. before the PKP starts. And see you all tomorrow. Bye.
Thank you, Dr.
Thank you, Dr.